Hello everyone, my name is Maoqi Lin. I'm gonna present my E591 final project on simulate SSFP brain MRI. I set two goals for my project. The first goal is exploration of SSFP sequence. The second goal is to simulate T1 and T2 images of brain with SSFP sequence. In the first, I wanna give a brief introduction of magnetization steady state. As we know, the gradient echo sequence can be divided into two types. The first type is residual transverse magnetization spoiled sequence. This sequence can be realized by two ways. First, when TR is far more than T2, the transverse magnetization will naturally decay to zero by the end of the cycle. Second, gradient spoiling are used to eliminate the transverse magnetization before next RF pulse. Another type of gradient echo sequence is steady-state sequence. If the transverse magnetization is not spoiled before next RF pulse, transverse magnetization will reach to non-zero steady state. If TR is small enough, the steady state of transverse magnetization and longitudinal magnetization are reached, and we call this sequence steady-state free precession sequence. By using this sequence, two types of signal are produced. The first type of signal is free induction decay, which is formed after excitation with the most recent RF pulse. The second type of signal is spin echo signal, which is formed when residual echo from the previous RF excitation is refocused by the current RF pulse. The bSSFP sequence is a kind of very useful steady-state sequence. bSSFP sequence means that the sum of positive gradient areas is exactly balanced by sum of negative gradient areas between RF pulse. So gradients applied in all three encoding axes are balanced. Both FID and spin echoes are sampled for image formation in bSSFP sequence. In this figure, the FID and the spin echoes overlap. In addition, the bSSFP sequence is extremely fast and is relatively insensitive to motion and blood flow-based dephasing. I use MATLAB code from block equation simulation website to do the bSSFP simulation. The figure indicates that the magnitude is very sensitive to resonant frequency, and it drops slowly over TR due to T2 relaxation. Also, the phase variation consists of regions of linear phase, with discontinuities of 180 degrees around the magnitude lines. And the point of TE is equal to half of TR. It is flat from one magnitude line to the next. This means we essentially have a spin echo as long as the frequency variation is small. When I do the simulation of SSFP brain, I choose T1 image of normal phantom from MNI brainweb. The parameter TE is equal to 10 milliseconds, TR is equal to 10 milliseconds, and the slice thickness is 1 millimeter. This figure shows 4 slices when flip angle are set as 30 degree, 60 degree, and 90 degree respectively. The color bar with different index indicates that different flip angle lead to difference in the magnitude of signal. Thank you.